Hi guys, welcome back to the discussion on vector ballet function. So in this lesson, we will continue the discussion on tangent vectors and normal vectors. We have learned from our previous discussion how to find the unit tangent vectors. And from those examples, there are also infinitely many vectors that are orthogonal to the tangent vector t of t. So one of this is the vector t prime of t. And from there, it follows the property that when you take the dot product of the tangent vector t of t to itself, the product is equal to the square of the magnitude or length of t of t. And because t of t is a unit vector, the square of the length is equal to 1. Also, the dot product of the tangent vector to its derivative, denoted by t prime of t, is equal to 0 na because t of t and t prime of t are orthogonal of each other. So, by normalizing the first derivative of the tangent vector denoted by t prime of t, you will obtain a special vector which is called the principal unit normal vector. So, by definition, let us define what a principal unit vector is. Okay, so let's see be a smooth curve represented by r on an open interval I. So if the first derivative of the tangent vector denoted by t prime of t is not equal to 0, then the principal unit vector at any time t is defined using this equation. That the unit normal vector n of t is equal to the first derivative of the tangent vector divided by its length or magnitude. Okay, so as an example, suppose you're given a vector ballet function r of t is 3ti plus 2t squared times j. So we need to find the unit normal vector denoted by n of t and the specific unit vector when t is equal to 1 for the curve now represented by r of t. So to find the normal unit vector normal to this curve, we have to differentiate the given vector r of t. So the first derivative is the derivative of the first component. So you have 3i plus the derivative of the second component. So this is 4t times j. And then we need to find the length of this derivative, which is equal to the square root of the square of the first component, which is 9, plus the square of the second component. So we have 16t squared. So to find the tangent vector, we have to divide r prime of t by its length. Again, recall that r prime of t is 3i plus 4tj divided by the length, which is equal to the square root of 9 plus 16t squared. Okay, so to find the unit normal vector, we differentiate the tangent vector t of t, and then we divide this by its length. Okay, but what is the first derivative of the tangent vector t of t? So assuming that this is your first function u, then you have the second function, so you apply product rule, wherein you have here the first function times the derivative of the second. Derivative of 3i plus 4tj is 4j. Okay, plus the second is 1 times the derivative of the first. But the first can be written in exponential form as 9 plus 16 t raised to the second power raised to negative 1/2. And the derivative of this can be executed by applying the power rule. So you bring down the exponent, which is negative 1/2 times u, where u is 9 plus 16 t squared raised to negative 1/2 minus 1, which is negative 3/2, times the derivative of u. Derivative of 9 is 0. Derivative of 16t squared is 32t. So we divide 32t by negative 1/2. So we have negative 16t. Then we place this in the denominator, changing the sign of the exponent from negative to positive. So we have 16t all over 9 plus 16t squared raised to 3 halves times 3i plus 4tj. And then we get the LCD. The LCD is 9 plus 16t squared raised to 3 halves. Then we divide this LCD by each of this denominator. So LCD divided by the denominator of the first fraction. So we have 9 plus 16t squared times the numerator. So you have 4j times 9 plus 16t raised to the second power minus LCD divided by LCD is 1 times the numerator, which is negative 16t times 3i plus 4tj. So because 4 is common for both terms, so by factoring this out, 9 plus 16t squared times j are the terms remaining. And then minus, we factor out 4 from 16, so this becomes 4t. So times 3, you have negative 12t times I. And then 4t times 4tj, you get 16t squared j. Since this is negative, so this should be negative. And then we combine like terms. So yung 16t squared j plus negative 16t squared j is, this is 0. Okay. And then from 9j and negative 12ti, the common is 3. So we factor out 3 from each of these terms. So 12 divided by 3, so we get 4. And since this is preceded by negative sign, so negative 4ti, okay, plus 9j divided by 3 is 3j. But 4 times 3 is 12. So you have this times negative 4ti plus 3j divided by 9 plus 16t squared quantity raised to 3 halves. Then after that, we need to find the length. We take the square of the first term. So the square is 16t squared plus the square of the second component, which is 9, divided by the square of the denominator, which is 9 plus 16 t squared quantity raised to the third power. If you take the square of 12, we have 144, but the square root of 12. So therefore, the length of the unit tangent vector is equal to 12 times the square root of 9 plus 16t squared divided by 9 plus 16t squared quantity raised to the third power. And because 9 plus 16t squared is common both in the numerator and denominator, so you cancel this out. So this becomes 9 plus 16t squared quantity raised to the second power. And when you take the square root, you have 1 over 9 plus 16t squared times 12. So therefore, the length of this unit tangent vector is 12 over 9 plus 16t squared. So to find the unit normal vector, now we divide the first derivative of the unit tangent vector by its length. Recall that t prime of t is 12 times negative 4ti plus 3j divided by 9 plus 16t squared raised to 3 halves. Okay, divided by the length of t prime of t, which is 12 over 9 plus 16t squared. So we change division to multiplication, but we get the reciprocal of the length of t prime of t, which is 12 over, or 9 plus 16t squared all over 12. And because 12 is common, so you can cancel this out. And also, you can cancel out one factor of 9 plus 16t squared to this. So you have negative 4ti plus 3j all over 9 plus 16t squared raised to 1 half. Okay, so this is our principal unit normal vector. So to find the specific principal unit normal when t is equal to 1, we replace all the t variable by t. So this should be negative 4 times 1 times I, so negative 4i, plus 3j all over 9 plus 16 times 1 squared is, this is 16 plus 9, so you have 25. and square root of 25 is 5. So therefore, the principal unit normal vector is 1 over 5 times negative 4i plus 3j. So as you can see in this figure, this is your r of t, or the curve. This is the unit tangent vector, which is perpendicular to this principal unit normal vector. So they are perpendicular of each other. So the angle between them is 90 degrees. And if you look at the components of the unit tangent vector, the x component is equal to the y component of the unit normal, and the y component of the unit tangent vector is negative of the x component of the unit normal vector. Okay, so one of the important concepts that you need to understand in this lesson is that whenever you have this curve represented by this vector valued function r, to find the unit normal vector, you have to first find the unit tangent vector. And then after that, you get the first derivative of the unit tangent vector and divide by its length to find the unit normal vector, denoted by n of t.